Quantitative literacy, this is the review for the Unit 3 test. Number 1, we're looking at the sum of two dice, so we're using this table over here. What's the probability that the sum will be less than 8? So let's count how many ways it's less than 8. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 ways. So that's less than 8, 21 of them. Or a multiple of 5. Okay, so now I'm going to count the multiples of 5. How many times that comes up? So that would be either 5 or 10. So that happens 1, 2, 3, 4, 5, 6, 7 ways. I'm going to add those together, but then I have to subtract off the overlap, meaning what numbers did I double count? I double counted these 5s. I counted them in the less than 8 category, and I counted them in the multiple of 5 category. So there were 4 numbers that I double counted. So altogether, that'll give me 24. And the total amount of different options is 36. So this is 24 out of 36, and then I always reduce if I can. 12 goes into both of those, so that reduces to 2/3. For number 2, I have the numbers 1 through 15. This is that conditional probability. Remember how I do this is I look at the second event, and that's going to reduce down my sample space. So this is saying the probability of B given A. Well, event A is that the number is prime. So the prime numbers from 1 to 15, be careful, 1 is not a prime number. So they are 2, 3, 5, 7, 11, 13. Those are the primes, numbers only divisible by 1 and themselves. So my sample space has been reduced down to 6 total numbers. Now I say, okay, now I look at the first event, B. So what's the probability that the number is even? So looking at just these orange numbers, the only even one is 2. So there is one choice out of those 6. So it's a 1 out of 6 chance that I pick an even number, given that my number is prime. For number 3, 2 cards are dealt without replacement. Find the probability that the first is a jack. Okay, so there are 52 cards. 4 of those are jacks. Now, without replacement means that assume that I took a jack out of the deck. That means for the second card pick, I only have 51 cards left because I took one out. Because again, this said without replacement. A jack is a face card because the jack has a face on it. Remember, there are 4 jacks, 4 queens, 4 kings. Those are your face cards. So there are 12 total face cards. But again, assume that I pulled one of those out. So now there are only 11 face cards left. Multiple events, I multiply the probabilities together. This would be, you could reduce this before you multiplied, but you can do it this way as well. So I get 44 out of 2,652. 4 goes into the numerator and denominator, and that will reduce down to 11 over 663. Again, I wanted a simplified fraction for my answer. For number 4, basically we're looking for a queen. Hustler has 3 cards face down, only one of which is a queen. So assuming he's not cheating, what's the probability of selecting the queen 3 times in a row? So 1 out of the 3 is a queen. Each time I have a 1 out of 3 chance of doing this, multiple events, I multiply the probabilities together. Across the top, 1 times 1 times 1 is 1. Across the bottom, 3 times 3 times 3 is 27. So overall, I have a 1 out of 27 chance. For number 5, we're in Jurassic Park. The unconditional probability of getting bit by a dinosaur is 0.6. If you're already bit, you start to bleed, the next dinosaur smells you. Therefore, the probability of getting bit by a second dinosaur after dinosaur 1 bit you is 0.75. The probability of being bit by a second dinosaur if the first one did not bite you is only 0.35. So this is one of these where I've got to figure out each one individually. So first thing, what's the probability of being bit by Dino 1? Well, that is just the first dinosaur. You have a 0.6 chance. Oops, a decimal there. Not being bit by Dino 2. Okay, now here's where you got to think this through. The first dinosaur bit me. The chances of the second dinosaur biting me is 0.75. That means the chances of the second dinosaur not biting me is 1 minus 0.75, which will end up being 0.25. So it's basically saying there's a 75% chance the second dinosaur would bite me, which means there'd only be a 25% chance he didn't. And then for the third dinosaur biting you, again, look at what happened before. The previous dinosaur did not bite me. And it says the probability of getting bit by Dino 2 if Dino 1 didn't bite you is 0.35. So the probability of being bit by a dinosaur after not being bit is 0.35. And so I'm going to multiply these together. So this is 0.6 times 0.25 multiplied by 0.35. I multiply all that together, and that's going to give me 0.0525. For number 6, this is going to be that expected value stuff that we did near the end of chapter 11. So a game is played by rolling 2 dice and summing the numbers. If you roll a 7, you win $15. Okay, so we got to figure out what's the probability of rolling a 7. If you look back on your paper to the table of the dice rolls, let's get that erased. A sum of 7 happens 6 times out of the total of 36. So a sum of 7 has a 6 out of 36, and if you reduce that, that's a 1 out of 6 chance. The probability of rolling an even number, well, the evens are all of these. If you count all of those up, that's half of them. That's 18 out of 36, or 1/2. So the probability of an even is a half. The probability of some other odd number that is not 7, well, the 7 was 6 chances. 18 minus 6 is a 12 out of 36 chance. which is a 1/3. If you count all the odd numbers that are not 7, there's 12 of them. 12 out of 36 is 1/3. Actually, let's change the color on that one. So I've got my probabilities. The next step in expected value is I multiply the event, which in this case is going to be the gross, times its probability. So 15 times 1/6, which is really 15 divided by 6, is 2.5. 5 times 1/2 is also 2.5. 9 times 1/3 is 3. I add these together. That gives me my expected gross winnings. So if you add those together, you get $8. If the game costs $10 to play, what are the expected net winnings? Well, I take my gross winnings, 8, minus my costs, 10. That's going to leave me with an expected net of negative $2. And again, typically your net in any kind of gambling game is going to be negative, or it should be. On number 7, we're finding our measures of central tendency, our mean, median, and mode, and then also standard deviation. What I would do first is sort this data from least to greatest. So I have 7, 11, 11, 14, 22. So the mean, which is X bar, is just add them up and divide by how many I have. They add up to be 65. And there are 5 of them. So 65 divided by 5, the mean is 13. The median, which is also Q2, second quartile, is the number in the middle. Since there are an odd amount of data values, the middle number, which is an 11, is your median. The mode is just if a number appears more often than others. 11 appears twice. So that is the mode. For the standard deviation, that's that complicated process. Now on the exam, I do have the steps for the standard deviation listed, but you just got to remember what to do each step. So find the mean, we've already done it. The next step is to find the deviations of each value from the mean. So if you remember, that is take each value, subtract the mean, so 7 minus 13, 11 minus 13, another 11 minus 13, 14 minus 13, and finally 22 minus 13. The next step was to square each one of these. If I square each one of these, that's going to give me 36, 4, 4, 1, 81. The next step was to find the sum of these squares. If I add those up, I get 126. Let's make that a little cleaner. The next step was kind of weird. We divided by n minus 1. So n is how many data values I had, which was 5. So n minus 1 is 4. Gives me 31.5. And the last step is to take the square root of that. That will give me my standard deviation. And I'm just going to round to 1 decimal. End up with 5.6. For number 8, we're comparing to bowling scores. We're going to be finding z-scores here. So for Drew, we take his score. He shot a 214. We subtract off the mean, which is 186, and we divide by the standard deviation, which is 15. That will give me 1.87. So Drew was 1.87 standard deviations above average. Amy shot 221. Subtract off the mean for her league. The standard deviation for her league was 13. Amy's z-score is 2.08. So relatively, Amy did better because she is more standard deviations above average. So she shot better on the raw score, 221's bigger, and by comparison to her league, she did better as well. On number 9, this one goes back to finding a mean. We talked about this in the notes as well. We are doing the GPA for a student with the normal 4.3210 for the grades. So math, the student got a C, so that counts as 2. And A is 4, B is 3, and so on. Now remember, we can't just average those numbers. We can't just average those because different courses are worth different amounts of units. So what we have to do is multiply the grade by the number of units. Add those together. If you add those together, you get 48. And now be careful, I'm not going to divide by 5. I'm going to divide by how many units total the student took. If I add up the number of units, they took 17 units. And GPAs are typically written rounded to 2 decimals. The student had about a 2.82 GPA. All right, we'll stop the video here and I'll finish up the rest of this on another video.